Hi, we're going to be talking about some work calculations in inclined planes. I know Mr. Arndt did that video yesterday about levers and mechanical advantage, so we're going to talk about inclined planes mechanical advantage and how the work stays the same. It's just your input force that changes. So we have here an example. We have our input force of input force of 40 newtons if we're using an inclined plane. If we're not, our output force would be 200 newtons. That's how much this actually, the weight of it. Okay, so that is our force is our mass times gravity. You don't need to worry about that. But basically, this, if we just lifted it up directly, the 1.25 meters would take 200 newtons of force. And so we're trying to look and see what the difference would be in our work between these two scenarios. So we're starting off with the work of our output force. So I've done this example. So what happens if we just took this box and lifted it directly up the 1.25 distance? And that's our output distance. And you can see that right here on my example. So how we're going to calculate our work is by multiplying the force times the distance. So we have our output force and our output distance. Our output force is 200 newtons, as you can see right here. Our output distance, if we just lifted it directly straight up, is 1.25 meters. Okay? So you're going to take your calculator and you're going to multiply 200 multiplied by 1.25. You have 200 newtons per meter, or actually what we say instead of newtons per meter, because that's kind of confusing, is we say, it was 250. What we say is 250 joules. Okay? Now, our second example, what happens if we use the inclined plane? Our height is the same. It's still 1.25 meters, but now we have a slope here as well, and that's going to be 6.25 meters. That is our input distance. We have the same box, but it only requires now 40 newtons of effort. So the amount of force that we have to put in is less. So when we're doing the calculation of this one, it's going to be our input force multiplied by our input distance. Our input force is 40 newtons. Our input distance now is longer, 6.25 meters. So the great thing about an inclined plane is it allows you to use less force. However, there is a trade-off, like Mr. Arndt talked about the other day. The trade-off is you have to push it farther. So yes, you have to put in less force, but the distance you have to travel is much greater. When you multiply with your calculator, you also get the same answer. 250 newtons per meter, or 250 joules. What this demonstrates is you require less force, but the overall work is the same. Okay? You may have to put less force or less energy in. However, overall in the system, the amount of work that is being done is identical. So that is the important thing to remember. Hello again. I just anticipate some questions about the inclined planes because I think the first part of this video could have been a little confusing. So I'm just going to clarify. You can watch this if you want to. You don't have to. But we're going to talk about some examples that you might get and why understanding the work calculations is important, because it can also help us work backwards and see how much less force we need to put in. Okay, so let's do a question where we work backwards. All right, so we're going to start on the first part of our example by just having an output distance of, let's say this is 3 meters. And we have a box or an object that we're going to be moving. And we're going to state that this has a force of 400 newtons. Okay, that is our output force. So make sure that's clear so you can all see. We have an output force. All right, so if we're doing our work equals force times distance calculations, let's really break this down, and I'm going to do it in different colors so it makes sense. So let's just start with our 4 steps like we normally would in math. Step 1, show what you know. Work is, we don't know. That's what we're going to be calculating. Force. Our force is 400 newtons. And our distance, we do know, is 3 meters. Okay? So using these, and again, remember, if you have your triangle here, I'll set it up for you one more time so that you remember how to use this. Okay, we have work on the top, and then we have force and distance over here. Remember, you cover what you're looking for. So in this particular example, we are looking for work. So we're going to cover work. Remember, when things are beside each other, it means multiply. So step 2 is formula. Work equals force times distance. Step 3, you put your information in. So work equals 400 newtons multiplied by distance of 3 meters. Step 4, you calculate. Now I don't need a calculator for this because remember, you can go 4 times 3, it's 12. And you add your 2 zeros. So that means newtons per meter, or 1,200 joules. Great. That's if we were just lifting this object directly up. Now, we're going to calculate our force advantage when using an inclined plane. So we have the same 3 meters, right? Same distance. However, now we're going to spread that out over a larger area. Let's say our distance here is, let's go with 8 meters. Okay, so we're really spreading that force out. So my question is, now, what is my force that I have to input now? Is it less? Well, yeah, we know it should be less, right? Because we're spreading it out over a larger distance. But if you were watching my other part of this video, you'll know that the work is the same. So when we do the what do we know, the work we do know, okay? It's 1200 joules. We just calculated it here, right? Same distance. And again, this only works if your height is the same, right? So we have 1200 joules. The force is what we don't know, right? We're trying to figure this out. Our distance, we know. It's 8 meters. Now we have to find our formula. Remember to cover what you're looking for. So if we're looking for force, our formula is force equals work divided by distance. Remember, the W on top means divide. So our force is going to be 1200 joules divided by the distance of 8 meters. You take your calculator, 1200 divided by 8, and our force is 150 newtons. Okay? So, this required a force of 400 newtons. This inclined plane only required 150 newtons. You can see it's a lot simpler to move this box. Yes, you have to move it over a larger distance. However, it requires less effort. So then you can talk about a ratio at this point. And this is where mechanical advantage happens. So how much simpler is it to move this object using the inclined plane rather than just picking it up? So when we're talking about mechanical advantage now, it's simply a ratio between these two. So what that's going to look like is you're basically going to take your output force and divide it by your input force. Right? This is how much we only had to put in. This is how much it put out if we just lifted it up. So our mechanical advantage is going to be 400 newtons over 150 newtons. Now you can get an exact number. So if you take 400 and divide it by 150, you're going to get 2.6 repeating. So that means it's you can't see that. That means it's 2.6 times easier if you're using the ramp as opposed to if you don't. Now, times easier. Or you could simply do a ratio. So for this, I'm just going to basically, what you're doing is converting it into a fraction with simplest form. Now, if you have a calculator that does that, you just go 400 over 150. It'd be the other way around. And it would be an 8:3 ratio. Now, what you could also do is get rid of your zeros. So it's like a 40:15, right, ratio. Yeah. Which is equivalent to 2 2/3, but in ratios, we don't really use a fraction. So we would simply just say it is this much effort compared to this much effort. In this example, it's probably simpler just to convert it into a number, because conceptually it's easier to understand that using this incline plane is just a little over 2.5 times easier than just lifting up that box. Okay? I hope that answers some of your deeper questions. Again, as per usual, if you have any questions about this, please send myself or Mr. Arndt an email, and we will see you next week. Thanks, everyone.